All right, on these last two equations, we're going to use the same methods, but they do have fractions in them, so they're going to be a little bit more challenging. Okay, so 2x plus 1/4 equals 3/5. So if I'm using inverse operations and reverse order of operations, I'm going to start by subtracting 1/4 from both sides. But since these two fractions do not have the same denominator, I need to find a common denominator. So I need to find a number that both 5 and 4 will go into. And I know both will go into 20. 5 will go into 24 times. So I'm going to multiply the numerator by 4 also, which is 12. And 4 goes into 25 times. So I'm going to multiply that numerator by 5. And now I have 12 twentieths minus 5 twentieths, which is 7 twentieths. So I'm left with, I'm going to bring down that 2x, and I get 2x equals 7 twentieths. Lastly, I need to undo multiplying by 2, so I'm going to divide both sides by 2. If I divide the left side by 2, I get 1x, because it cancels out. And if I divide the right side by 2, it's the same thing as multiplying by 1/2. So I'm going to rewrite it as 7 twentieths times 1/2. So 7 times 1 is 7. 20 times 2 is 40. So that means x is equal to 7/40. And I'm going to plug it back in just to make sure. So 2 times 7/40 plus 1/4 is hopefully going to equal 3/5 if I did everything correctly. 2 times 7/40 is 14/40 plus 1/4 equals 3/5. I'm going to rewrite 1/4 with the denominator of 40 because I know 4 goes into 40 10 times. So that's going to be 10/4 or 10/40. And then when I add 14 plus 10, I get 24/40. And if I reduce that, I can divide them both by 8. 24 divided by 8 is 3. 40 divided by 8 is 5. So it is 3/5. So it does check. Last but not least, again, fractions. But again, I'm going to use order of operations. So I'm going to start by adding 3/4 to both sides. And I should have said the reverse of order of operations. So this one cancels out. I can't add 1/6 and 3/4 until I have a common denominator, so I'm going to rewrite them both with the denominator of 12. 6 goes into 12 2 times, so 2 times 1 is 2. 4 goes into 12 3 times, so 3 times 3 is 9. When I add those together, I get 11/12. So now I have x divided by 3 equals 11/12. The way that I'm going to undo dividing by 3 is to multiply by 3. So I'm going to multiply it on the right side by 3/1. I can reduce the 12 and the 3 by dividing them both by 3. And then I get 11 times 1, which is 11, and 4 times 1, which is 4. X equals 11/4, or 2 and 3/4. So I'm going to plug it back in just to make sure. 11/4 divided by 3 minus 3/4 is hopefully going to equal 1/6. So if I do 11/4 divided by 3, that's the same thing as saying 11/4 times 1/3, which is 11/12. So then I'm going to do 11/12 minus 3/4. And if I rewrite 3/4 with the denominator of 12, I get 9/12. 11/12 minus 9/12 equals 2/12, or 1/6. So thankfully it checks. Hopefully this was a good review of solving two-step equations using inverse operations. and the reverse of order of operations.